Okay, so today we're going to take a look at solving radical equations and inequalities. As we go through the lesson in class, we're going to break it down to your radical equations, single, double, exponents, and then our inequalities. Okay, but this video will cover everything all at once with an overview as we go through it. Okay, so we're going to start with this warm-up. We'll do it in class, so I'm not going to spend time going over it in the video. So the first thing is we're going to look at single radicals, okay? And we kind of already know how to deal with them because we've solved square root equations before. But the main thing is you're going to want to get your radical completely alone. This can involve doing things such as adding or subtracting or multiplying, dividing numbers away from the radical. And you actually want to make sure you do it in that order. Always add or subtract before you multiply or divide. Okay, once you get it alone, so as you can see in the example here, I had to divide by 2, and then I got my root by itself. You're then going to raise to the power of the index of whatever your radical is. So in this case, it was a square root. So my index is 2. I raised to the second power. It was a cube root. I raised to the third, fourth root to the fourth, etc. Step 3 is then you're solving your resulting equation. So by raising the radical, the square root to the square, it undoes itself, the insides fall out, and then 2 squared is 4. Easy enough for me to solve. Subtract 1, I get x equals 3. Now some of your solvings might have to include a little bit more than just simple one-step equation. You might have to solve a quadratic as well. So just be prepared for that. And then the last step is you want to check your answers for extraneous solutions. So an extraneous solution is an answer to the problem that you had mathematically, but not necessarily an answer to the original problem. What you're going to find is most of the time that comes with problems that you're solving with quadratics. A single value, just like this, x equals 3, it's going to work, or it should work as long as you solved it correctly. But you do want to get in the habit of checking. So you plug the 3 back into the original equation and you work your way through simplifying it, and it does work out to the right side. So basically plug into the left, see if it equals the right. Okay, and we'll be going through these problems in class. And you can kind of see here, like in B, I'm going to have to add the 1. Anything not under the root, I got to move it. So I can get it by itself. This would be a case in which we had to solve with an extraneous solution, right? I square both sides. I didn't have to worry about moving anything. When I squared it, I was left with a quadratic. You can solve quadratics by square root method, by factoring like I did here, by the quadratic formula, whatever works for you. And I got 2 answers, x equals 9, x equals 1. When I did the check of each of those, okay, so I plugged it in to both sides, and you simplify one side and the other, okay? You want to see, does the left side in fact equal the right side? So when I do that for 9, it works. But when I do it for 1, over here, you can see it comes out to 1 minus 4 is a negative 3. There's no way a square root is going to become a negative. So 1 does not work. So in this case, 1 is an extraneous solution. 9 is my actual solution. But you do have to show both, and you have to show which one is extraneous. And it's not always going to mean you have extraneous, by the way, with your quadratics. You can have both of them work within the problem. So you do have to check it. You can't just assume one will work, one won't. And again, we'll practice through that as we go through them. Then we're going to get into multiple radicals. When you have multiple radicals, it means obviously you're going to have 2 or more radicals in the problem. If they are not identical and I can't combine them as like terms, then I have to make sure one gets completely alone. And basically I do a double solving. And the best way to show you is by showing you. So you can see here, I have 2 radicals. I have one on the left, one on the right. The one on the right is completely alone. So my main focus is going to be that one. One of them has to be by itself. Doesn't matter which one. But if one's already alone, start there. So you square it so you can get the 3 minus x to drop out. Now, when I square the left side, I have to write it twice and FOIL it. Please don't be scared by the foiling with the radicals. Okay, when you FOIL, just take it step by step. Square root of x plus 2 times the square root of x plus 2 means there's 2 of them, right? We've done that before. Square root of x plus 2 times 1. Then we do the 1 times each of them, and we're able to combine our like terms and clean things up. So I was able to cross out the square and the square root from the first set. They undid each other. I combined my middle two radicals to make them 1. Then I moved everything else over to get that radical alone. Then I repeated the process. Now I have a single radical, so I can square both sides, get the radical to fall. Negative x squared is a positive x squared. And then I move everything over. And again, I'm able to factor in this case and solve. When I put the 2 in, the 2 does not work. Clearly does not come out to be the same answer. But when I plug a negative 1 in, that one did work. So 2 is my extraneous solution in this case. And again, we'll walk through, practice a couple of them. Okay, the next part is rational exponents. A rational exponent, a fractional exponent, is the same as a radical. Remember, the denominator represents the root, the index of the root. Okay, so again, just like before, we want to get the radical part alone, which means get the rational exponent by itself. So you can see in this example, I subtracted the 2. Now here's the difference. Before, we raised to a whole number power. Now we're going to raise to the reciprocal power. For example, 1/2 is 2 over 1, or vice versa. 3/4 is 4/3, or vice versa. So in this case, it was 3/4. So if I raise it to the 4/3 power, the 4/3 and the 3/4 will cancel because they come out to 1. So the 2x drops down. We're lucky enough, 8 to the 4/3 ended up being a whole number. If it didn't, then you have to write it as an exponent, or you can write it in the radical form. Most of yours will come out to nice whole numbers, and solve it. You get x equals 8. And again, we're looking for extraneous solutions that we can cross out in case they don't work. All right. So a few things to keep in mind, though, that even denominators means, so this is a 4th root is what this means. I can't have negatives inside. So if I was to plug in that and I got a negative number, so I was trying to do negative 16 to the 3/4 power, probably wouldn't be able to work it, right? You would put it in calculator, it's going to come out as an error. So just keep that in mind as you're going through these. And again, we'll practice them throughout class. And the very last thing we're going to take a look at is inequalities. Inequalities are solved the exact same way as equations. The only difference, obviously, the inequality symbol. Less than, greater than, less than or equal to, greater than or equal to. You have to remember a few rules. If you multiply or divide by a negative, you flip the symbol. And we have to consider every possible value of the radicand. So we know that the values are going to be either greater than or less than or equal to's. So this biggest issue is with our even roots where we can't have negatives. So in this case where it says x is less than or equal to 17, that's great, but it really can't be less than a point that's going to make this interior 0 because I can't have a negative number on the inside here. So in that case, we have to have an even root restriction. And all that means is you take the inside of your radical. This is only for even roots. So if this was a cube root, a 5th root, a 7th root, we wouldn't have to worry about it. But square roots is an even number. You take the inside, you take your radicand, set it greater than or equal to 0 because you want it to be bigger than, you want it to be a positive number, bigger than 0. It can equal 0, that's fine. And you solve it. So x has to be greater than or equal to 1 because at 1, it makes the inside 0. But it also has to be less than 17 because that's the answer we got when we solved it. So I put both of those together. When x is greater than or equal to 1, but also less than or equal to 17, you get this compound inequality. 1 less than or equal to x, less than or equal to 17. Okay, so it's going to be important as we go through this that we keep in mind these even root restrictions. Now, if it's an odd root, like I said, it doesn't matter. And if it was a number greater than, say this was greater than or equal to 17, again, it wouldn't matter because I'll have positives inside. So really, the biggest issues come from even roots that have less than problems. Okay, and again, we'll go through and practice all of these and do some fun word problems as well.